Hi, everyone. So today we're here to present some proof of work that we've done in this quarter. And our team has worked on a Solana Rust client extension. Our team is led by Arthur and me, Apollo, and Manoj. We're there to assist him in the project. So in our class, Berg proposed a challenge. So he had some kind of Solana client extension, which was very interesting. But the challenge was, if we were able to use the SVM API to kind of optimize transactions in very different ways, and the start would be to use, if we could simulate compute unit use, instead of using the traditional RPC call, we would simulate the SVM, to calculate it to make it more efficient, and then also using it to optimize the transaction in various ways. So this is the goal: build a trait extension on the Solana RPC client to locally make compute unit aware transaction and craft it and optimize it. Arthur?
So our main functionalities here in the trait extension, we are estimating CU based on the message on it. We are estimating CU unsigned, so we unsign the transaction and do it locally. As Apollo was saying, we could do this calling RPC method, but we want to do it locally and simulate it before we send it to RPC. So yeah, we optimized the CUs, and one of the last features that we implemented was the possibility to optimize the prioritization fees, because we saw in the RPC methods from the Solana DevNet that we can simulate prioritization fees based on the CUs. So we are already estimating the CUs, and now we can like estimate the prioritization fee based on that CUs. So yeah, we have these features. So the compute budget structure that will do the simulation of the CUs, and this tag profiling that make the user the possibility to specify a tag, so it can simulate a transaction only with the CU simulation or with the prioritization fee simulation, and then we can put an arbitrary tag to make things more clear when you're testing everything under our local development. And these tag-specific results are to analyze the CU patterns on it. So yeah, we prepared a little demo video for today, and one of our tests that is simulating the CUs, simulating the prioritization fee, and also tagging that simulation locally. So yeah, here is the video. As you can see, we have this test. We are creating a account, we're creating a transaction, and then we pass this transaction through our roll-up channel. The transaction here is to simulate a transfer between two users in LAN ports. So yeah, we create a channel and we pass this analysis config. That is what we are tagging. So here you can see the estimate compute units as true, the calculate prioritization fee as true. So we will simulate both of these simulations, and then we pass a tag, an arbitrary tag that I passed at demo tag. So we can see on the test running that we have this tag showed out on the. Oh, oops. So here we are gonna simulate the test, and as you can see, we run the test and we see the LAN ports being transferred from a user to another. We can see that the compute units, our tags that we passed arbitrarily in the tests. We can also see that the CUs consumed was 150 CUs, and we can see that the 3 per LAN ports are 0 now. And after later in the video, I will call RPC method to the actual DevNet, and then we can see that at this moment, it's actually being 0 LAN ports per CU on that moment. So that's the RPC method that I'm going to call in the actual Solana RPC methods. As you can see, it's 0 now. So our simulations locally are representing what's actually happening on chain. And then I leave the word for Manuel to share our roadmap on this extension.
Yeah. Thanks, Arthur, for running the tests. I'll quickly walk through what's next or what's possible for the future project. First, we are exploring some ways to grab accounts directly from mainnet and simulate them locally. So this would let us capture both the pre and post account state, which is super useful for debugging and inspection program logic, especially when it comes to CPI heavy flows. And secondly, we plan to build, a tag-based CU profiling dashboard, some kind of, UI to look at. The idea is to give the developers a clearer picture of how compute units are used across tagged operations like swaps or mint, all in one place. And thirdly and finally, we're working on a custom dynamic priority fee recommendation engine, which is impossible otherwise before, helping you avoid overpaying or getting stuck in queue. Would you go to the next slide? And yeah, as a final note, this work actually caught the attention of the Surfpool team, and Arthur was invited to collaborate with them and bring these features into their protocol. And Surfpool has already started implementing and have released these features onto their latest release, and is now iterating on new ideas based on the feedback we generated through this project. So it's exciting to see our work, already influencing real-world tools.
Yeah, so that's it.
Thank you.
Thank you, guys. You can check the repo. Here's the link I can send you in the chat. And yeah, thanks, everybody.
This project started as kind of a fascination with FastPay. You might know about it. Facebook implemented this documentation and created this doc about FastPay, which implements faster transactions and more finality and more security when we are transferring funds. So in this, what they promised was they were promising 100 ms speed, which is unheard of. And with the new development of Help and Glow, it is irrelevant of the geographical location. So yeah, that's what started. Let's look into what's happening here and dig more into it. So what FastPay does is they create a sender, they have their own structs, and then they create transfer orders, which goes to FastPay committees, which are neutral committees like validators who validate whether this transaction would go or not. And then they would send over a signed transfer order, and based on the signed transfer order, we'd again send a confirmation order that yeah, this sender is confirming that this transaction is going to happen, and then we update the committees to change the whole state. So that is what FastPay does. So when we wanted to implement this in Solana, we had some problems, specifically the sender parts, because what FastPay tried to implement was creating their own structs and implementing them natively in their code. So what we thought and what we have implemented is we have a user wallet, and we have a source SVM layer and an L2 layer. So what we are trying to is kind of make an interop layer between the L1s and the L2, and make some message forwarding from L1 to L2 or L2 to L1. So in here, what we have accomplished here right now is we have this user wallet, and on the SVM layer 1, let's say, we have this contract that would let's say I want to transfer some funds from my account to Bidan's account. So in this case, this contract would first escrow my assets, and then this would log all of the details about the transfer order that we want to do, and those transfer order details would be picked up by the indexers, and those indexers would then put all of these transfer order to a neutral committee that is off-chain, for obvious reasons, because we want this committee to be neutral irrespective of whether it is a transaction for L1 or it is for L2. So that is why we chose a neutral committee here. This neutral committee is a BFT committee, so we know that even if some nodes are faulty here or they do not give correct answers, we are not relying solely on them. So what we are implementing differently as compared to FastPay here is the indexer would first pick up the details from the contract, that is what transaction is happening, and based on that we'll first send it to the off-chain committees. They'll sign our transactions, and those signed transactions would again come back to the indexer, and then the certificate would be generated that certifies that these neutral committees has certified that this transaction is happening and can happen. Once that is done, we'll have a relayer that can multicast all of these events, like these transfer orders that we have certified, and those orders can then be put on the any layer that we want, like say Sonic L2, and there the smart contract would verify the 825519 signatures, and based on that we'll create a wrap token, and that wrap token would be minted to the user's account that we want to transfer to. So that is the core thing we are trying to implement here. As for the solutions, there is mostly ChatGPT generated. These are the key innovations. Of course, the Byzantine fault tolerance that we are pushing forward, that yeah, this consensus can handle up to 1/3 of the authorities being compromised. And sharded architecture, there is a slight caveat here that we are using to make it more efficient. That is, all of the authorities create shards. Shards are, you can understand them as the processes, and those processes would process only the accounts would have some hash. They would have some hash. I can probably show you after this. They have some hash, and based on that hash, we'll have the sharding. We'll have the shards that can process those accounts. Like these shards will only process these type of accounts. So in this way, the authorities are not bombarded with all of the accounts, and they don't have to worry about every account. So that is what we're trying to make efficient here. Then there are the threshold signatures. We get the signatures from the authorities and create a certificate. Once all of the signatures are transferred to us, and once the certificate is created, we can just simply pass it on to a contract that is on whichever L2 we want to transfer it to. So let's try building it. Yeah. So this is a start auth. This would start all of the authorities. This would take a while. Here we can see this is a bridge authority, and it has started listening on this IP, and we are creating sharding servers that I just told you about. These are the processes that are individually working to operate on the transactions that are from specific accounts. Like there is a function there that operates whether this shard will get which account. Okay, once all of the authorities are up, we can probably start something. Yes, once that is done, we have a relayer here. That indexer and relayer, we have coupled it down to a simple one unit that can index the blockchain and as well as relay all of the certified transfer order to the destination L2 we want to transfer to. So this is the command for that, and we are not listening right now because we cannot implement that. We're just creating a dummy instruction for now. Once that is done, we can see in the logs that it first pulls the source chain, and the sender public ID is generated. It would go to the shard 1. That is because when we look into it, into the byte array, the byte array would get modulus by 16. So that gives us 1. That is why we are going for the shard 1. And once that is done, we create a dummy transfer. The dummy transfer would then be processed, and they would be sent to all of these shards. And because we have just created 4 authorities, these transfer order would be sent to the shard 1 of the authority of the 4 authorities. So once all of the signatures are here, we can understand that the quorum threshold has been reached. And once that is done, we can create a certificate. Once that certificate has also been generated from all of the authorities, we can submit the certificate to destination chain. So this is just a proof of concept for now, but we are thinking of implementing it on, let's say, first on local validators and then moving forward from it. So yeah, thanks. And yeah, the sharding function. Yeah.
Great.
All right. I think I'll find it. What was it? It was get shard. There is a self get shard, and what it does is simply it takes the sender, and the first byte of the sender we just modulo it by 16, and that is how we get our shard IDs. And based on that, the transaction would get sent to only the shards that we are getting from this get shard ID. So yeah, thanks.
GM folks, we are the Agave sitemap group, and we are here to improve the developer experience on the Solana protocol layer. So our team consists of me, I'm Manish, and Vivek, and David. So the main challenge which we are actually trying to solve our project is to enhance the overall developer experience for Solana developers by providing a clearer and more intuitive overview of the various components and processing stages within Agave. Agave is a complex and powerful transaction processing engine, which is at the heart of Solana, but its internal working can be difficult to navigate and understand by developers who are actually coming in. So by surfacing detailed insights into the Agave's architecture, such as the pipelines, the fetch stage, the SIG verify stage, the banking stage, the thread interactions, and the performance metrics, we aim to demystify the system for developers. So this improved visibility will not only accelerate debugging and performance tuning, but also empower contributors, researchers, and ecosystem builders to innovate more efficiently on Solana's core infrastructure. So I'll walk you through our project. So here currently we have our block building stage ready, where if you come to our website, you will first see an interactive visual map where you can go to each stage, and also let's say I go to fetch stage, I can see what are the relevant file paths. I can also see what are the important code structures and also their roles and the key functions, right? And here's the fetch stage, which we have actually prepared. Here you can see that each of the components of the fetch stage, which are really important, are actually mapped and put it here together. And also the other stages, such as the SIG verify stage, the POH stage, the broadcast stage, all of them have their particular components mapped here together. And most importantly, the banking stage, where we have prepared the banking stage into a whole detailed overview so that any developer coming in can easily have a great overview of the banking stage. Let's say, and when I click over any kind of particular component here, let's say the consumer, I can get a whole overview and a whole detailed information of what it does and what are the important code structures there. I can also copy them into my clipboard and use them as we need. So all of the components here are interactive, and as we go further down the line, we can see what are the things which we need from here. And apart from that, we are here. If you see that there's this button called the cloned banking stage to your repo, which will help us to clone a particular sections of the Agave repo which we have. As we all know, the Agave section, like the Agave repository itself, is a huge repository. So this steps will help us navigate to what are the things we need to check out to view only the banking stage or the stage which we are actually viewing, and the stages which are actually required that we are trying to analyze. So yeah, that's what our project is.
This is a video on Pinocchio, and this video is for developers who are new to Solana or are migrating from Anchor. So I can give you a short analogy to explain you Pinocchio in a better way. So normally you can go to a store and buy a car, but like that car will not be the best as in performance. And if it comes to F1 cars, like you can choose every single part, and same way, like you can choose every single dependency and things in Pinocchio. So what is Pinocchio? Pinocchio is a zero dependency Solana library. It has no external dependencies, and it is very lightweight because of that, and it is purely made for performance and optimization. When like you come to Pinocchio, you might get confused with the approach you want to take in building stuff on Pinocchio. You can have, like, you can choose your approach. Like you can choose bytemark plus zero copy, or bytemark without zero copy, or totally do it without bytemark, doing it direct access. But what is the best way? So like the main developer Fibo said, you should avoid the unsafe code as much as possible. So try to use bytemark as suggested by Fibo himself, and try to use bytemark with zero copy. But if you are confident enough, then you can go for direct access. And now I can give you some like practices or recommendation to use. Like you can of course go for bytemark plus zero copy, and like try to use byte array, and also try to keep in mind the padding. Okay, on when it comes to zero copy, like try to use zero copy, please. Like if you don't use zero copy, then like the benefit is not high of using Pinocchio. So try to use zero copy. And now I'll show you a project or a program that I've made. I try to implement a few of the basic programs into a single program, like vault implementation, an escrow contract, and an NFT staking program. I've done all three into a single program, so like developers can take inspiration from this example and understand it better in a better way, like Pinocchio in a better way. So this project is related to tuition payments that is made in Pinocchio. The two main users for this are university administrator and students. So university admin can register the university to the protocol and add multiple subjects and degrees, and each degree can have an NFT collection, and that's get minted by the protocol. And I can give you a suggestion, like try to avoid doing the front end, like try to avoid initializing mints in the Pinocchio program itself. Try to do this part in front end. And now comes a journey for the student can enroll themselves to the protocol, and when they pay a first semester fee, NFT gets minted. Yeah, and while minting the NFT, I'll just suggest you the same thing, like try to do the initializing part in the front end to save the CUs, and yeah, the rest of minting can be done there. And now comes the payment cycle. In payment cycle, when student pays their first semester fee, it automatically gets staked into the NFT gets freeze in the wallet, and when they are done with their last fee for the semester, like for the degree, their last fee, it gets unfreeze or unstake from their account. So staking works like their authority for the ownership shifts to a PDA instead of the student. PDA will have the ownership, and when it gets unfreeze, the student will get back their ownership. So this was it, and this video is for like developers who can take inspiration from this, and this is the link for the repository. Thank you.